everybody. Welcome to your geography class. This is our 6th standard and I am Mamta. So, let us start with our first chapter, the earth and the gratitude. So, what we are going to learn in this lesson is trying to find the exact location of a place on earth. Let us start with an example. We have the Taj Mahal here. And I have one student Ram here, one student Lakshman here and one student Sita. Now, very quickly let us brush up on our directions. You know, this is north, this is south, this is east and this is west. So, I ask Ram, how do you get to the Taj Mahal? And he says he has to come down and go left. So, that will be southeast for him. So, Ram says Taj Mahal is southeast for him. So, when I ask Lakshman, how do you go to the Taj Mahal? He says he has to go up and right. So, that will be going north and going east. So, Lakshman says Taj Mahal is northeast to him. So, when I ask Sita, where is the Taj Mahal? She says it is on the west. So, I am getting 3 different answers for one location. Taj Mahal is in Agra, it is in one and only one location, but I get 3 different answers. So, this does not help me. So, I need a system where we can find the unique, the single answer to the question. So, if I ask them where is the Taj Mahal, they have to give me only one answer. So, let us see how we can do that. So, in this system what we do is we have to draw imaginary lines on the earth. So, because we cannot actually draw imaginary lines on the earth, we take something called a globe. A globe is a small model of the earth. So, we can draw imaginary lines on it both vertically and horizontally. Let us see how we do it. So, we start with the earth here. And the first imaginary line that we are going to draw will cut the earth into 2. So, this divides the earth as the northern and the southern hemisphere. This is called an equator. So, this is the first imaginary line, this is the northern hemisphere, and this is the southern hemisphere. Now, what happens is when I cut this, I get something called a plane. Let me show you how to do that. Now, I have a potato with me and I am going to show you what a plane is. So, imagine that this is the earth. So, if this is the earth, then this is the equator. So, if I cut it, you get a plane. So, this is the plane. So, imagine you have the plane at the center of the earth. So, this is the equatorial, we call it the equatorial plane. So, this I call it the equatorial plane. Now, I can take any point on the earth, and this is the center of the equator, center of the earth. So, let me take any point on the earth. Let me take this point, and what I do is I have to draw a line from that point on the earth to the center of the equatorial plane. So, as you can see, this is again an imaginary line and it forms an angle with the plane. So, that angle, that imaginary line, so let us say this is 30 degrees. So, it is called 30 degrees north because it is on the northern hemisphere. So, what happens is even on this side it will be 30 degrees. So, now let us join them because this gives us another plane. What happens is anywhere on that plane, all the places are 30 degrees. We have some places at 30 degrees. We have New Orleans in North America, which is 30 degrees north. We have Cairo in Africa. So, this you can see is parallel to the equatorial plane. Let us say we have one more point here, say 60 or 70 degrees. It will be same, we will make one more line, one more imaginary line and one more plane. So, let us draw one more circle here. So, this again is parallel to the equatorial plane. So, what happens is, let me join the 30 degrees here, let me join the 70 degrees here. So, what happens is every time you have some degrees of latitude, on the same side you have the same degrees of latitude, and when you join the 2 points with a circle, they form different, as you can see they are all parallel to each other. So, these are called parallels of latitude because they are all parallel to each other. So, the maximum that you can have is 90 degrees in the north and you can have 90 degrees in the south. So, as you can see, the degrees will increase as you go up, it goes all the way up to 90 degrees, but the parallels become smaller and smaller, so much that when you reach the end of the 90 degrees, whether it is north or south, it becomes a point. So, this point you call the North Pole. And this again is a point that becomes your South Pole. Okay, the equator is at 0 degrees. The equator is at 0, it is called a 0 degree parallel. The equator is also called a great circle because it is the largest parallel, the biggest circle. In all, we can have 90 degrees of latitudes on the northern hemisphere and 90 degrees on the southern hemisphere. We also have the 0 degree of the equator. So, we have a total of 181 parallels of latitude that you can draw. So, you have 90 degrees in the north, 90 degrees in the south. So, if you draw it every single parallel, if you draw it at a 1 degree difference, let me write this for you. So, you have from 1 degree north all the way up to 90 degrees north. These are one set of parallels. then you have 1 degree south to 90 degree south, another set of parallel, then you have the equator which is 0 degree. So, you have a total of 181 that you can draw all in all. So, these were one set of imaginary lines that we were drawing. These are called the parallels of latitudes. This gives us half of the information. Now, we need another side of the information which are called longitudes, and let me draw that for you. So, you can just take a quick look at this. We have the equator, we have the equatorial plane, and we have a latitude which is the angular distance from the equator. So, this 30 degree imaginary line that we are passing, that is the latitude, it is the angular distance from the equator, and we said anywhere on the surface of the earth all the 30 degrees will be the same latitude. So, that makes one circle. Similarly, we said for 70 degrees at this point the whole circle will have a 70 degree latitude on the entire parallel of latitude. Since they are all parallel to each other, they are called parallels. Totally we have 90 degrees that we can with the interval of 1 degree, we have 90 degrees that we can 1 to 90 degrees parallels that we can draw in the northern hemisphere, and 1 degree to 90 degrees in the southern hemisphere, and with the equator being a 0 degree, we have a total of 181 degrees that we can draw. So, this is one half of the information with regard to latitude. Now, we will see how we do the longitude. So, the latitudes are drawn dividing the earth into north and south. The longitudes will divide the earth into east and west, and let us see how it is done. Again we have the equator here, we have the center of the earth, we have the equatorial plane. So, this is our equator and this is our equatorial plane. So, I will call this M, it is center of the earth. Let me take one point A, let me take one point B, and let me take one point C. So, this will be AM will be 0 degrees. So, now let us measure the angle from B to M. Here I said longitudes will divide the earth into eastern and western hemisphere. So, this is our eastern, this is our western, this side. So, now if I draw a line joining B and M, and this center line, this imaginary line is called the prime meridian. Just as equator was the imaginary line dividing the earth between north and south, prime meridian divides, it is an imaginary line, it is 0 degrees, it divides the earth as east and west. So, now the angle that this makes with the prime meridian, let us say this is, because this is 90 degrees, this angle will be the distance from the prime meridian, that is called the longitude. Just as the latitude was the angular distance from the equator, the longitude is the angular distance from the prime meridian. So, let us say we have AMB. So, it is, let us say it is at 70 degrees, and then we have one more angle with the prime meridian joining our dot C. So, let us say this is 60 degrees. So, this again is one angular distance from the prime meridian, this is another angular distance from the prime meridian. Now, draw a semicircle touching the poles. So, we have one semicircle passing through B, and we have another circle passing through C. As you can see, they are touching the south pole and the north pole. So, these are called the meridians of longitude. So, what happens is a combination of this, the latitudes and the longitudes will give us the exact location. Just as we had 181 that we could draw for the latitudes, for the longitudes we have 360 that we can totally draw the meridians of longitude. The prime meridian is 0 degree, which is visible to us on this side of the globe. On the other side of the globe, which we cannot see, is the 180 degree meridian. Similarly, with an interval of 1 degree, you are able to draw from 1 degree to 179 east meridians and 1 degree to 179 west meridians. They are all at an interval of 1 degree. Okay. So, now let us see how it looks like when we bring them together. So, we saw the latitudes and now we saw the longitudes. So, you saw the prime meridian was at 0, it divided the earth into the eastern and the western hemisphere, and we saw the longitude, it is the angular distance from the prime meridian, and the on this side of the globe it is 0 degree, on the opposite side it is 180 degree. In all we have 360 meridians that we can draw. All of them are imaginary lines. Now, how does it look like? You have on your page how a graticule looks like. It is an intersection of all your latitudes and longitudes. So, here we have the pole. So, what happens is all the meridians should converge at the pole. So, let me draw the longitudes first. They all converge here. So, this is the pole. So, they are all converging there. And then you have the latitudes which go circular. So, this intersection is called, this net is called a graticule. So, the latitudes plus the longitudes together form a net. It is a network, you can see that. That net is called a graticule. So, what did we learn? Very quickly, we learned about the equator. It is the line passing through the center of the earth. It divides the earth between the northern and southern hemisphere, and we saw this equator, when we look it at this way, we saw the equatorial plane, and then what else did we see? We saw the latitude, which is the angular distance from the equator. Then we saw the prime meridian. Just as equator divides it into northern and southern, prime meridian divides into eastern and western, and we saw that the angular distance from the prime meridian gives us the longitudes. The intersection of these latitudes and longitudes forms a net, that is called a graticule. This gives us the exact location of a place. Now, there are two very important locations that you have to remember. The Tropic of Cancer runs at 23 degrees north, and the Tropic of Capricorn runs at 23 degrees south. Let me just write it for you, these are important. And these are parallels of latitudes, the Tropic of Cancer and the Tropic of Capricorn. Tropic of Cancer parallel latitude is 23 degrees north, is 23.5 degree north. It is actually a few minutes, so let me just make it 23.5. And the Tropic of Capricorn is 23.5 degree south. So, again these are the parallels of latitudes. So, what we will do now is, we will very quickly try to summarize some main critical features of our parallels of latitudes and the meridians. So, let me rub this for you. Just remember these two, Tropic of Cancer and Tropic of Capricorn. So, let us look at the characteristics or the features. I want to look at the features of the parallels of latitude. I also want to see the features of the meridians of longitude. So, I want to see with regard to the shape. First, I want to know the shape. So, do you remember how the parallels of latitude run? They are in the shape of a circle. And how do the meridians of longitude? They are in a semicircle. Next, I want to know the size. The size of each parallel is different. Parallel. But all meridians are of equal size. Thank you.